Stan Gibilisco here with a little further explanation of the way that a maglev train track operates. I kind of contradicted myself in the other video. I don't know if you caught that or not, but I was talking about what happens when you shut off the magnets that levitate the train above the track. Well, this all comes from Electricity Demystified, second edition, a link to which I will provide in the description of this video. Then we can take a brief foray to an exploding star in an unknown galaxy, in an unknown cluster of galaxies, in an unknown universe, in an unknown set of universes, in an unknown thought kingdom, unknown except for one thing: maglev trains. This is figure 12-15A from Electricity Demystified second edition. Just one, either one of the drawings, A or B, will suffice here. But if the magnets that levitate the train get shut off, either because of a power failure or a failure of the magnet system or something like that, this train car will settle onto the track, and the train will presumably come to a screeching halt. However, there's another set of magnets besides just the set that levitates the train cars above the track. And that is a set of magnets that operates in a timed manner, a very precise timed manner, to either push the train forward or pull it backward. Now, if you're on a slope, then you have to push the train forward with a certain amount of force just in order to keep the train staying still. If that force isn't enough, that train's going to slide back. If the force is more than enough to hold it still, then the train will move forward. It's very similar to what happens with your car or truck on a sloping hill when you're driving, or any other train. The engine has to be strong enough to pull that train up the slope, and the steeper the slope, the more pronounced the effects. Now, if that set of magnets should happen to fail, either going up a slope or down a slope, but the levitation set of magnets continues to operate normally, that train is going to start to coast faster and faster and faster. And depending upon how long the slope goes, that could turn into a runaway train, literally. Just like any other train if it loses its brakes or anything like that. There has to be a way to stop that train in the event that something like that happens. And generally, there's one way to do it is to shut off the set of magnets that holds the train car above the track by levitation. Then it will probably come to a really screeching, long, protracted, agonizing halt. But at least it will stop. Other methods can be employed, but that's one way to do it. But there are, in fact, two sets of magnets that levitate, that operate a maglev train. One is the set that levitates the train above the track, and the other is the set that pushes the train either forward or backward, and the amount of force required to do that depends upon the slope the train has to go up or down. If the train is going forward down a slope, you might actually have to apply a considerable amount of reverse magnetic force just to regulate the speed and keep the train from getting out of control. So it works pretty much like an ordinary train in that respect. I insinuated in the previous video that if you shut off the levitation magnets that the train would coast. Well, no, it wouldn't. That would be the way to make it stop. The train would coast if the forward or backward propulsion set of timed magnet sequences were to fail. Then you'd have a real problem, because that would present a genuine danger to the passengers unless there was a way to make that thing stop. And there is a way, the simplest way, as I said: shut off the levitation magnets. Stan Gibilisco signing off from that exploding star in the unknown thought universe, unknown except, of course, for maglev trains a subject about which I obviously know everything, and you'll find everything about maglev trains. I'm just kidding. But at least mention of them, and a whole lot more in my book Electricity Demystified, second edition, published in 2012, available at Amazon.com. And again, I will provide a link to the page so you can go there and, if you so desire, purchase the book. Stan Gibilisco signing off. Until next time, so long.